Hi, my name is John.
And my name is Alice, and this is Math Videos for Parents. We help you so you can help your kids with math. Today, we're talking about simplifying radicals. So, the method I had learned was the perfect square method. So, essentially, if I have something like the square root of 25, then the answer to that is 5. And the reason I know that is because to kind of do it backwards, 5 squared, 5 times 5 is 25. So with the square root, the index, that's this number here, it's implied, it's not stated, but it is a 2. If there's ever not a number there, it's 2. And so that's where this 2 comes from. So I'm asking myself, what squared is going to give me what's inside the radical? And it's 5 squared. And I honestly know that because I memorized it, because when I was growing up, we had to memorize them. So to take it a step further now, let's do the square root of 32. And I'm going to ask myself, okay, what perfect square is kind of lurking in there? So I know that 16 times 2 is 32, and 16 is a perfect square. So I can pull it out. 4 times 4 is 16. So I'm going to pull the 16 out as a 4, and I'm left with that 2 still under the radical. So that's going to be my answer. And again, if I wanted to check it, I love checking my work. I wish you could always check work in life. Then I would say, okay, is 4 squared times 2 equal to what I started with? And it is. 4 squared is 16. 16 times 2 is 32. So I ended up back where I started. Now, you don't have to check it. If that just gives you a headache, you don't have to check it. But I just like being able to do that. That right there is our answer. John, my understanding is there is a different approach now to simplifying radicals. So please enlighten us.
Sure. So nowadays, most students usually use prime factorization. And the reason for that is because a lot of times when approached with a number like 32, there could be choices for which square number to use. So if a student didn't pick 16 right away, but instead thought of it as 8 times 4, they might think they're simplifying the radical, but unless they go a couple more steps, they're not really simplifying it fully. So to take that guesswork and additional steps out of the process, one of the other ways we can use is through prime factorization. And the idea is to factorize 32 using prime factors. And since 32 ends in a 2, an even number, our best first guess is to divide 32 by 2 to get 16. Then we can divide 16 by 2 to get 8 and continue the process. So 8 divided by 2 is 4. And then 4 divided by 2 is 2. So what we have here is that 32 can be rewritten as a product of prime factors. All of these 2's that we uncovered through the prime factorization, plus this additional last 2 at the end when we broke up 4 into 2 times 2. So I have 2 times 2 times 2 times 2 times 2. And the idea with simplifying radicals using prime factorization is that whatever the index is, so like Alice pointed out, this index is really a 2 because we're doing a square root. For every 2 2's or whatever the factor is inside, we take out one of them because we're square rooting it. Like 2 times 2 is really a 4. And by taking it out, we're square rooting it to be a 2. So that comes out as a 2. This next group, this pair of 2's, that also comes out as a 2. The last 2, our fifth 2 that's inside, that did not have another 2 to make a pair. So that just stays under the radical because it didn't have at least the index to come out. So our final answer is 4 radical 2. I have heard of teachers explain this as using shoes. Like if you see 2 of the same shoes in a closet, you could take one out as a pair, which makes sense for this particular problem, but it can get a little problematic later on when we work with cube roots and higher roots in Algebra 2. We're not really going to have 3 shoes of the same type, so it could get a little confusing. So I recommend sticking to just finding whatever the index is, however many of those, you can take out a set of that many as one group and put that on the outside.
And I don't need any excuse to do factor trees, so I am pumped to try this method.
Great.
Okay, so now I'm going to solve for the square root of 72. And so I'm going to do it the method we just learned. So I'm going to make a factor tree. Now, 7 plus 2 is 9, which is divisible by 3. So I know that I can, in fact, divide by 3. So I'm going to put a 3 there. And 3 goes into 72 24 times. Now, 3 is a prime number, so this branch is going to end there. 24 is 8 times 3. Minor fact, 24 is my favorite number. 8 is 4 times 2. Again, 3 is a prime number, so that branch ends. 4 is 2 times 2. So, kind of gathering them all up, I'm going to have 3. I'm just looking at all the ends of the branches. So I could rewrite the square root of 72 as the square root of 3 times 2 times 2 times 2 times 3. And again, I don't know if I mentioned this, but I love being able to check my work. So if at this point you wanted to check your work, you could just run 3 times 2 times 2 times 2 times 3 through a calculator and make sure you get 72, which you will. So good job. Now what we're going to do is figure what we can pull out. So I'm looking for any number, because there's no index here. There's no index right here. That means it's 2. So I'm looking for any number that shows up twice. So I'm going to kind of chug along, and I see a 3 here, and I see another 3 here. So I can pull those 2 3s out, and I'm going to be left with 1 3 outside the radical. So I'm going to pull that out. Now I'm going to keep going. Maybe I've got another option. I see a 2 here and another 2 here. So I'm going to pull those 2s out and be left with 1 2 outside the radical. And now all I have left is a 2 that's all by itself, so it can't be pulled out. So 3 times 2 is 6. And what's left inside the radical is 2. So my answer is 6 square root of 2. John, what are your thoughts?
I really favor this approach because a lot of times when students see numbers like 72, they remember some math facts. They might remember that 72 is a 9 times 8. And while that is correct, what often ends up happening is they will take the square root of 9 and get 3 and think that they're done after 3 radical 8, but they're actually not, because 8 also has a factor of 4 in it. So if I break that 4 down a little bit more using the method you had learned, that would require an additional step. I would need to know that a 2 comes out of it that way. And from my experience with high school students, we see that a lot of them miss this extra step. So using a prime factorization helps avoid this misunderstanding and thinking that you're simplified it at this stage, but you actually aren't. So, and I also think it gels nicely with some of the earlier videos we had where we broke numbers up into prime factors to be able to better use them in a variety of settings.
So this method is foolproof, essentially. It's kind of like when you're missing a sock. You can't really say you don't have a matching sock until you pull everything out of the sock drawer.
True.
And this way you're pulling everything out and laying it all out, and you're saying, oh, these 2 match, with an index of 2, so they come out. Otherwise, like you said, things could be lurking, and you don't know, and you think you're done, and in fact, you're not.
Exactly. And when they get to Algebra 2 and they work with cube roots, if they use the list of perfect squares approach, now they need a list of perfect cubes. So that requires additional memorization and familiarity with new numbers that can easily be avoided if they take a larger number and break it down into prime factors and then just look for groups of 3. So it's a method that works across all problems, and it's not specific to just square roots.
And I think maybe next week we should do a video about cube roots. What do you think?
Yeah, let's do it.
Okay, wonderful. Well, thank you very much for joining us today. Please let us know if you have any problem requests. We'd love to help you out. This is Math Videos for Parents, and have a great day.
Thank you.